I know you cover Smart Meter Analytics for Guidehouse. If you could give a little bit of an overview for our audience of the smart meter market and, what are the kinds of use cases and trends that you're seeing now within that space?
It's an interesting space, obviously, very high growth. I think to look at the smart meter analytics market and kind of where it's headed, take a step back and look at, the actual smart meter market. So where are we with, kind of the penetration of smart meters? Are we seeing it on a global scale? I think the story is that the train has certainly left the station in terms of smart meters, primarily driven by Western Europe, North America, China, obviously a regional leader. I believe we're set to hit 1 billion smart meters according to our models by the end of this year. And so that's driving, a lot of data proliferation, a lot of utilities inundated with these massive data sets, not a ton of expertise historically in trying to manage these large volumes of data. So what you have is kind of opportunity for analytics to come in and provide value to maximize that and kind of, allow utilities to kind of maximize the values of their investments for the first times. So what we're seeing is this expanding list of use cases across the customer engagement and experience, grid optimization, now into things like DER integration and more advanced data management. So utilities using analytics platforms in a lot of valuable ways to try and maximize the value of smart meter and their underlying data, which again has been historically a challenge from a kind of investment and utilization standpoint.
You spoke a little bit about how utilities are utilizing this in their different platforms. Can you speak a little bit more about the techniques and the architecture that they're using to deploy these things?
From the analytics vendor perspective, there's kind of 3 different levels of kind of analytics models. Starting at the beginning, we have kind of static reporting and descriptive, what has happened. So that's used for kind of outage events, customer segmentation, what kind of basic analytics applications. What we're seeing now is a shift towards more predictive modeling and predictive analytics techniques. So across the home, across the grid, really trying to proactively predict and anticipate kind of changing grid and kind of customer conditions. And then ultimately kind of the holy grail is the prescriptive level where we actually recommend a set of corrective actions, whether it be on the grid or for the customer in a more automated fashion, which just introduces a lot more kind of cost and operational efficiencies versus the more kind of static or rudimentary descriptive-based analytics.
So you spoke a little bit about the use cases that utilities have as they're investing in smart meters and utilizing it. Could you speak a little bit more about those categories again in detail? Customer experience, demand response, network monitoring, and DER integration?
An easy way to delineate some of the kind of traditional smart meter analytics use cases, again, we're seeing across the customer side, the grid side, and then the DER side. So at the customer side, we saw, kind of lifted off the ground with the invention of home energy reports. So the Bidgeleys, O-Powers, Uplights of the world. A lot of focus on home energy reports, smart thermostats, more kind of basic customer-based use cases. That's evolved over the past 3 to 5 years into more advanced load disaggregation, customer segmentation, targeted web marketing. You see digital marketplaces popping up with increasing frequency. So really just more advanced use cases that really get at engaging with the customer and, optimizing that relationship between the utility, and their prosumers. On the grid side, a lot of load forecasting and kind of basic network management tools have evolved. And now we see more kind of advanced AI algorithms and machine learning around connectivity, voltage optimization, outage response, and more kind of automated decision-making in terms of kind of those grid optimization applications. And then in terms of DER, again, we've seen a lot of popularity among DER forecasting, whether that be embedded in your DERMS or as a standalone module. Where the more innovative or kind of interesting developments we see happening now are around DER detection and EV detection. So when we're talking about, how do utilities, plan for the future and how can they, best be future ready? A lot of that is going to be around the integration of EVs and solar PV on rooftops. And the detection tools are one way at which, utilities can be proactive in terms of, getting ahead and planning effectively for these new loads.
And I think that's what we're kind of also seeing with utilities as they're expanding into this clean energy future is how they can utilize the new grid edge technologies around those certain areas. Could you speak a little bit more about the kind of the grid edge and that kind of movement and the developments there?
Yeah, so that's been another interesting kind of evolution we've seen over the past 10 to 20 years, beginning at the transmission level, which has near ubiquitous connectivity and automation now. Just given kind of the cost and criticality of that network and its assets. Transmission kind of started this automation story. And then, the next evolution came with distribution automation, which is now becoming, fairly standard practice, right, via SCADA to have that decision-making at the distribution substation level. So where's the next evolution of this paradigm come? It's kind of really at the ultimate edge of the meter, or edge of the grid, which is going to be at the meter. So when we talk about kind of on meter analytics or inside the meter analytics, that's extending that automation and kind of decision-making to the home. When we talk about kind of the grid edge and kind of where the storyline starts and where it's gone, it starts, 10, 20 years ago with kind of the transmission network, where we saw kind of the first level of automation and connectivity come to light, where now, we have near ubiquitous connectivity and automation at that transmission level. At the distribution level, it's now fairly standard practice to have that decision-making at the substation level through SCADA. And kind of the next evolution in this paradigm comes at ultimately the grid edge at the meter. So when we talk about that, we talk about inside the meter intelligence, on meter intelligence, an idea that has had traditional technical barriers around bandwidth and latency, and just kind of the compute power of the smart meters themselves. But interesting developments from meter manufacturers to analytics vendors is changing that and kind of eroding some of those technical limitations that have kind of kept the grid edge paradigm back from its true potential.
Could you speak a little bit more about how some of the leading manufacturers of smart meter technologies are leading the way in their technology?
I'll mention two meter manufacturers that have been leading the charge in particular, Itron and Landis+Gyr. So Itron through its Riva meters, Landis+Gyr through its Revelo line of meters. What they've done is really broken down the traditional barriers to on-meter analytics, which has been, how frequently can we capture energy, voltage, and current? What is the onboard processing power and memory within our smart meters? And can we actually deploy any applications within those actual meters? So, starting at the top, this next generation of smart meters for the first time is capable of measuring waveform, which introduces a plethora of kind of pattern recognition capabilities and more grid visualization capabilities that were previously untenable with first generation meters. We can also capture these now 4 different data types at sub-second intervals. So that opens up a lot of new potential in terms of kind of real-time intelligence rather than leveraging those 15-minute or even hourly kind of time intervals. They've also been really successful in terms of upgrading kind of the computing power and onboard memory of these smart meters. So a lot more kind of power in terms of what these kind of mini computers can do at the edge of the grid. And then finally, we've seen both Itron and Landis+Gyr create this kind of open ecosystem, and they're attracting analytics partners to try and develop local agents, more or less applications that can run on these new kind of powerful smart meters.
So you spoke about Itron and Landis+Gyr, and I'm wondering if you can speak a little bit more how they're working with partners like Bidgely Analytics partners to kind of leverage their technology, maybe in a kind of partnership ecosystem, if you can explain that a little bit more.
Yeah, absolutely. So again, both Landis+Gyr and Itron have gone with this framework of working with utility analytics partners in this more open ecosystem environment. So for Itron, for example, has their distributed intelligence platform in which they're engaging with analytics providers that can develop local agents, essentially applications that run on top of the Itron meter in kind of an open ecosystem, which is going to be, I think, critical in terms of kind of fostering innovation in, an open standards market. So it's really, working with multiple utility partners on use cases that they have expertise, around, and creating an open environment where utilities can kind of pick and choose and have more flexibility in kind of the value proposition that they want to bring to their customers.
For the Itron and Landis+Gyr meters, these smart meters that are deploying, we've been hearing from their reports that smart meters are accelerating across the world. How much of that penetration is actually happening in regards to this kind of smart meters?
Yep. So that's an interesting question. So very nascent today. I believe Itron has around 2 million Riva meters deployed to date. That's largely a function of just kind of the temporal way of how first generation smart meters were rolled out, right? North America and Western Europe, North America at least was largely through the Smart Grid Investment Grant, 2011, 2012. Western Europe, a lot of nationwide rollouts. That began several years ago. So the technology just simply wasn't there at that time, right? So if we look at kind of the average meter lifetimes, when we expect these meters to be replaced, there are several or a handful of deployments, to date across the States and pockets of Europe. But what we're going to see in the next 3 to 5 years is most of these first generation deployments that, were deployed, over the course of, a few years are all going to be set for replacement, in the very near future. So utilities will have a choice whether to kind of go with the status quo and stay with kind of that more rudimentary technology, or invest in kind of these second generation smart meters. And a lot of utilities are under pressure to kind of maximize the value of their smart meter investments. And I truly believe these second generation meters bring a lot more value to the table, or at least a lot of more potential value creation for utilities that want to invest in analytics and kind of explore how they can maximize the ultimate value of their investments. So I'd say that, as you see these second generation smart meter projects roll out, you're going to see, the frequency of this, more advanced meters, and that penetration rate grow accordingly. And that really just kind of opens up the total available market for these more advanced smart meter analytics solutions and meter hardware.
Are there any particular regions or accounts that you think folks should have their eyes on in terms of having those kind of new applications deployed?
I think, when we talk about these more advanced use cases, second generation smart meters, inside the meter intelligence, North America and Western Europe are probably going to be the hot spots, at least for the near term. Largely a function of, these are the regions that deployed smart meters first, right? So when we think about what's the average meter lifetime, when are these meters eligible for an upgrade, it's largely going to be in those regions that I mentioned, at least in the near term. When we look at more emerging markets, I think you're still going to see a propensity for kind of that first generation of smart meter models and technologies. But that said, we have seen kind of that average meter lifetime go from 20 years now down to, I would say, between 8 and 12. So what you're going to see is a lot more frequent upgrades, a lot more kind of moving up to that next generation of smart meters, I think, a lot quicker than, a lot of people had initially anticipated.
I'd like to ask another question related to the technology and these kind of like CPUs on the meter. A little bit more, if you could explain maybe inside the meter architecture around those, such as, I've heard a little bit about fan and HAN level, communication level, insights level. What are those differences and why they matter?
So I think the interesting conversation there is around kind of the complex trade-offs that utilities are facing in terms of whether to go with, say, an on-premise analytics solution, a cloud-based analytics solution, or now with this new evolution of kind of on-meter or inside-the-meter analytics. So when we talk about FAN versus HAN, home area networks, HAN, is going to refer to kind of your on-meter or inside-the-meter analytics. What we're talking about is, that smart meter making that decision and then sending a command through the home area network to the consumer. When we talk about field area networks, that is kind of more at the level of on-premise or cloud-based architectures, where that data from the smart meter is being sent over said field area network to a cloud data server or a hosted data server. Now, with those field area networks, you have some inherent limitations. One, bandwidth. Do you really want to send kind of all this data through the communications network back to the back office? It's been one thing when you have 15 or 30-minute data intervals, but when we talk about sub-second data intervals, and now you're introducing waveform, a new data stream, essentially you have kind of a new level of kind of data influx to deal with and a lot of congestion. So that's going to introduce some bandwidth constraints, and it just doesn't make some of these use cases feasible. There's also the latency considerations when we talk about sub-second data streams. When we're talking about use cases that demand real-time intelligence, we really need low latency between the communications network to facilitate kind of actionable intelligence. So So with on-meter analytics at the home area level, you have that ability to kind of actually maximize and use that sub-second data, where it's fairly illogical to send it over a field area network, because the insights are just not going to be kind of as high value as you would get with the more localized paradigm.
Perfect. And I think that leads in really well, because I think our audience is, they're eager about second generation meters as well, but wondering kind of what are some of the new use cases that you can leverage with those meters.
Again, largely led by Itron and Landis & Gyr to date, but these analytics ecosystems supported by a number of partners, we've seen use cases be developed around customer experience and engagement, demand response, network monitoring, and DER integration. I'll mention a couple use cases that I think are particularly interesting, or I see value, particularly in the near term. One is around EV charging and time of use and kind of peak pricing. So one of the use cases that we've seen some interest from utilities and vendors alike is, if a customer is EV charging during a higher price time period or peak pricing, what we can do is disaggregate that EV or DER load in real time, and then alert that customer that they're charging during a time in which they might be paying more. Now, if you were to send that information over a field area network to the cloud or to an on-premise analytics architecture, you really lose that real-time value proposition. Whereas, as an alternative example, something like an AC malfunction, you might have a 1-day time window there where you can still provide value. But when we're talking about peak pricing or time of use alerts, there's a lot more kind of real time nature to that insights. So that's one that I think is kind of particularly interesting. The other is around demand response. And this idea of kind of active demand response, transformer management. That's an area in which by using kind of peer-to-peer communications, location awareness that are all kind of enabled by this distributed intelligence or inside the meter paradigm, you're able to kind of actively control demand response resources in a more localized manner, in a more real-time fashion than you'd get with the more traditional analytics architectures.
Can you also speak a little bit more about network monitoring and DER integration capabilities under second generation meters as well?
Absolutely. Yeah, I'd say there's a lot of interesting use cases being developed right now around kind of the grid management, grid optimization side of the coin. When we talk about outages, everything from detection of the outages, restoration of that power, and then notifying the customer, all use cases that are being kind of developed inside the meter and can deliver more real-time intelligence to utilities and customers alike. On the voltage side, obviously, a lot of technologies being developed around volt-var optimization, conservation voltage reduction. That's an area in which sub-second voltage data streams from those smart meters can be applied and more effectively analyzed for kind of the next level of voltage level insights. Feeder phase balancing, one thing that again is enabled at a more local level by some of these inside the meter paradigms, and can just provide kind of a different level of intelligence over your on-prem or cloud-based architectures, because you're really getting that sub-second near real-time intelligence at the grid edge and those more localized decision making.
Got it. Great.
And then on the DER side, what we're seeing is, again, that kind of a blending of use cases where you have something like EV charging and time of use. When you put them together, maybe separately you could do EV charging or EV detection at a 15-minute interval. But when we talk about time of use and peak pricing and combining that with some of those DER use cases, that's where the value prop really increases, behind multiple different applications.
Great. Sounds like there's a lot of operational benefit as well as a new kind of customer engagement benefit that can happen when we're doing real time.
Absolutely.
Analytics.
There's a lot of, again, it's not just, benefits for the utilities or the customers. A lot of these, applications that are being developed have those kind of dual benefit value propositions for the utilities and the customers alike.
And this is great to hear, because I think it's going to be extremely important for utilities as they transition to clean energy and they have to address maybe natural disasters or things that happen much more quickly in a more reliable and fast manner.
Absolutely.
It's been a pleasure talking with you today. I wonder if you have any closing thoughts for our audience around the capabilities of these smart meters and what's coming.
Yeah, so I think there are, a few key takeaways that really tell the story in terms of this evolving paradigm. At the meter level, you have a handful of manufacturers that are developing more advanced, powerful smart meters capable of sub-second data capture. And at the analytics level, you have companies like Bijli and others that are developing really advanced AI-enabled algorithms that can now be embedded, within the smart meters themselves. And then third, it's a nascent market today, but it won't be for very long, right? You have, across North America and Western Europe, you're seeing an uptick in this kind of the frequency of second-generation smart meter projects. And utilities are under, immense pressure to try and maximize the value of these second-generation deployments. One logical and I think feasible way to do that is what these inside-the-meter technologies and architectures. So it'll be, exciting market to keep track of over the next 3 to 5 years. But as you see these kind of upgrade and replacement projects come to market with increasing frequency, I think the total available market for these types of solutions grows, alongside.
That's wonderful. If folks have more questions and want to learn a little bit more or kind of follow the smart grid trend, what are some resources Guidehouse has to stay in touch?
Thanks. So yeah, we maintain, a number of research services, a number of reports that touch upon kind of the ideas we discussed today. One of which is our global AMI tracker. So that's a kind of an interactive database that we maintain that tracks global smart meter projects actually at the utility level. So we can look at, across different countries, across different regions, which are the utilities that are deploying, what are their time frames, who are the key vendors involved. And it's a way to kind of look at the market from, again, not only that utility level, but can slice along regional lines or vendor-based lines to try and isolate kind of what are the key trends in the market, across a number of different dimensions.
Pleasure talking with you.
Awesome. Welcome back, everyone. Had a great session just now with Michael Kelly, who's joining me from Guidehouse Insights. Michael's the Senior Research Analyst and Managing Consultant there. Thanks, Mike, for joining us.
Yeah, thanks, Jeff. Happy to be here.
So really good session. Appreciate you kind of giving us that more intimate look at the advanced metering market and progression in terms of innovation and opportunities. One of the questions that we had right off the bat was, should utilities start to evaluate and look for disaggregation capabilities from smart meters now or in the future? Kind of what's your read on sort of the timing of that as an important ingredient in their decision making?
Yeah, definitely. An interesting question. A lot happening around the disaggregation space. So disaggregation tools have actually been leveraged for several years as a function of some first generation deployments. Though there has been a notable shift in the way the tools are being utilized. So traditionally, these tools were more of a nice-to-have solution, provide utilities and customers with more granular insights into their electricity usage. But with advancements in some of the predictive prescriptive analytics algorithms and techniques, in addition to this inside-the-meter paradigm, we're seeing use case shift to provide now grid services and now more meaningful and impactful applications for the customers. So, for example, disaggregation tools can now be leveraged for system-level modeling, visibility through bottom-up modeling. Can be used to let the customer know when they've activated an appliance or an EV during a higher pricing period. So, really enables more real-time action on behalf of utilities and their customers to provide more enhanced value props.
Yeah, so it's definitely become more than just a nice visualization. It's truly a tool on sort of multiple silos within a utility and then across those silos. Quick question. When it comes to an end customer, what do you think that line is for them between sort of the hardware and the software of their meter? How do you foresee their engagement and management of their energy with respect to these new devices that exist in the world that should make it conceivably easier to be an energy consumer?
Yep. So, when we think about this customer-centric future, as it pertains to smart metering, both hardware and software are going to be critical parts of this foundation. So, while initially smart metering hardware provided the bulk of benefits for utilities and their customers, decreased meter readings, more accurate billing, some basic outage management practices, the shift we've seen in the industry towards more data-driven approaches and application has kind of shined a light on some of these more advanced software applications, where we've seen more value propositions being led by advanced meter data management systems, dedicated customer analytics, dedicated grid analytics. Now with this inside the meter paradigm shifting back a bit, where we're seeing more importance on the actual hardware, right, in terms of increased memory, computing power, that's enabling some of these more localized analytics applications. So really, it's a blend of kind of powerful innovations across hardware and software that are going to touch the customer as we approach these next generation deployments.
Yeah, that makes a lot of sense. I mean, maybe let me play off of that and ask you, it all makes sense when you start to list out all the positive qualities that come along here, but what are common challenges that you're hearing from the utility side of the fence in terms of being able to fully deliver on that benefit, whether it's operational or customer or both? What are they running into?
Sure. So, one thing I hear from utilities a lot is this idea of data management problems and data quality issues. Right? Even simple kind of mapping problems like meter to transformer and phase identification. Those are some existing gaps across a lot of utilities. And that's, been a barrier or a constraint where some utilities want to get their data up to a certain quality before deploying some of these advanced applications. And I think what we've learned is, for a lot of these tools, with some of the data management capabilities kind of built in to some of these embedded analytics applications, is you don't need perfect data to get a positive value proposition out of some of these solutions. If anything, some of these tools can help you isolate some of those gaps in your data, where you can still achieve some positive benefits while rolling out the software and do it in a stepped approach. So those traditional data management constraints, I think, are still there from a perception level. But in terms of the on the ground, reality, I think that barrier is quickly eroding.
Yeah, that's really interesting. I think insightful, right? That, so often the goal is the data, but then it's also the problem, right? In terms of putting it all together, having it look perfect, getting started with less than perfect data. So there's obviously been some utilities that have been more proactive, going on a decade of advanced metering infrastructure to a degree. But when it comes to utilities, have you noticed a difference in terms of uptake of this technology, either by fuel type or geography or market dynamics? Have you seen any of that? And if so, what is your opinion on maybe why?
Yeah, certainly. So we've seen, obviously smart meter adoption increase across the globe. In terms of, some particularly interesting areas, I think, Australia, when you think about DER integration, some of those Southeast Asian markets, when we think about EV adoption, that's where, these next generation smart meters can provide more value around things like EV detection and disaggregated solar and EV profiles. Transactive energy markets, which will ultimately have to rely on these more advanced devices that can perform, that sub-second data capture. So as we see, the first generation smart meter deployments reach the end of their life cycle, and we've seen that, average lifetime be reduced from 20 years to now around 8 to 12 years. You're going to see this large scale upgrade and replacements across North America and Western Europe, and that's where you're going to see this market start to open up in terms of next generation smart meters, more localized analytics, and more advanced algorithms powering these underlying software platforms.
Yeah, definitely. So I hear you saying sort of more of those macro level market dynamics pushing some of our earlier adopters, and that same wave sort of pushing through to maybe our later stage adopters in even North American or other markets. You mentioned a few cases like EV charging just now, some of the peak pricing stuff. When a utility is looking at that, is there an expected return on investment that they have around a particular use case, or is it really a summation or an aggregation of all of their use cases that goes into their decisions they're making around advanced infrastructure?
Yeah, so it's going to be a summation of those different use cases, right? There's going to be different value props depending on the particular use case that you're looking at. But what we see is, one, on the analytics side or on the software side, some vendors are leveraging common algorithms for multiple use cases that can reduce some of those kind of initial cost outlays and the integration and implementation complexities. Again, with this kind of emerging inside the meter paradigm, you have major meter manufacturers partnering with analytics providers, and they're just developing local agents on top of those smart meter applications. So it really facilitates a more kind of open environment, more potential applications and use cases to leverage off that one same meter. So you're not going to need multiple pieces of hardware running different analytics use cases. It's really consolidating around these kind of open, vibrant partner ecosystems that'll help kind of reduce all those traditional barriers.
No, I love it. I love that open market model. I think it drives innovation, and I know Bidgely's excited to be a part of it with some of the meter manufacturers as well. I'll leave you with sort of one last question, which is, you've mentioned so many use cases from the operational side to the customer side, and probably some that haven't been said. If there were one use case that you think is sort of on its way towards sort of maybe market adoption or innovation that isn't sort of commonly discussed one, right? This idea of presentment or even some of the DR stuff, what might it be? What can you kind of give us a preview to in terms of that next level use case using, high res data from advanced metering infrastructure?
Yeah, certainly. So when we talk about, this inside the meter intelligence, more enhanced data streams, I think demand response is probably one of the, most logical areas in which I see, some positive value. When you have, meters that have, location awareness, have kind of meter to meter device communications, that idea of having more localized demand response events, more real-time dispatch and kind of control of those demand response resources without the bandwidth and latency constraints of some of those traditional architectures, it's a natural play. And as we look towards, a transactive energy future with, peer-to-peer trading and these local power pools, this is going to be the technology of the future that's going to help drive that.
Perfect. Thanks, Mike.
Appreciate it, Jeff.
Yeah.